looking at what we call survey techniques. Survey techniques, that is surveying. Let us look at this example. Find the area in hectares. Find the area in hectares of a piece of land whose measurements are entered in a field book as follows. These are the measurements. You are told, take xy is equals to 400 meters. 400 meters as the baseline. 400 meters as the baseline. So our baseline starts from x all the way to y, but y should be at 400 meters. So what do? You first draw what we call a sketch of the piece of land. A sketch. Draw the sketch. How do you draw the sketch? You first draw the baseline from x to y. From x to y. Remember y is at 400 meters. You draw it horizontally. So you come and draw something like this. Maybe you can use a ruler. So you come and draw the baseline horizontally like that, starting from x. Fix your x there. Okay? So, learner, from x, you go and put a mark. You put a mark at 80. You approximate, you say, let this be 80 meters. Write it there. From there, you go and fix 200. You just estimate. If this is 0.80, this is 200. Let's assume it's about somewhere here. 200, somewhere there. We continue, we go to 280. Let's assume 280 learner is somewhere like there. We go to another point here, 360. We are continuing with our baseline, 360. And finally, learner, you go to y, and y is at 400. Take care of that. Some students omit that. So y is at 400. So you come and fix your y here at 400 meters. How do you like that? Maybe you can fix the y here and 400 meters there. Good. So learner, we have drawn our baseline horizontally. So it's like we brought it down this way. So this is the right hand side of our information here, and this is the left hand side. So if you draw the baseline horizontally like that from x to y, then whatever is to the right, we call these offsets. The offsets to the right will go below the baseline, if you turn it clockwise. This and this will go below. At 80, we have an offset to P. At here, we have 200 meters. You come and fix it there. 200 meters to P. Let's assume our P is somewhere there. Okay? And remember, these offsets, they meet perpendicularly with they meet at 90 degrees with the baseline. Then you go to 360. At 360, we have an offset to Q, and it is 80 meters. You come and draw, you approximate. If this was 200, maybe we can fix our 80 there. Our 80 meters to where? To Q. So the offsets to the right go below. They go below the line. And these offsets to the left, they go above the line. So we go to the offsets. At 200, there is an offset 160 meters to S. So at 200, we have an offset here, which is 160. You come and assume, let this be 160 to S. So you come and write 160 meters to S. You go to 280 to 280, you have another one here, a shorter one, 80. It's like half of this, 80. An offset here, let's assume it's up to there, to what point? To R. And you write here 80 meters. Remember, all these offsets meet perpendicularly with the baseline. With the base, with the baseline, like that. So learner, from there, you complete your sketch by joining these points. You join the points now to complete the sketch. Join this to that. Join S to R. Join S to R. Join R to Y, like that. R to Y, something like that. You join P to X. Continue. P to Q. And finally Q to Y. Q to Y. Something like that. So learner, you now have your sketch of the piece of land, and all the measurements are in meters. So learner, you come and label these regular figures, plain figures, as A. You can call this A, call this B, C, D, E, and F. So how do you find the area of this piece of land? You first find the area of all these plain figures, all of them, and finally you add to get the area in meters squared. So let us do it. What is the area of A? Area of A. This figure here is a triangle, and therefore, this figure is a triangle, therefore our area is a half times base times height. A half times base times height. So a half. What is our base? Our base learner is from here to here, and therefore it is 200. From here to here it is 200. And our height is what? Our height is 160. 160 meters. So you work that out, you can use a calculator, and therefore you get 16,000 meters squared. 16,000 meters squared. You go to B. B, what is the area of B? B is what? This is a trapezium. This is a trapezium. How do you find area of a trapezium? You talk of a half, sum of the parallel lines. Sum of the parallel lines, 80 and 160. 80 and 160. And then you multiply by the perpendicular. This is your perpendicular line. This is your perpendicular. How will you get it? 280 minus 200 gives you 80. Gives you 80. You work out this, you get a half. This plus this is 240. 240 multiplied by 80. You work out this line, you divide, you can use a calculator, and therefore with this, you get 9,600 meters squared. We go to C, learner. C, our C. What is C? C is a triangle. C is a triangle, and therefore we talk of a half times what is our base from here to here. That is 400 minus 280. 400 minus 280, learner, will give you 120. So our base is 120 and our height is 80. You come and fix it here, then you can divide using a calculator, or you can just do it by cancelling out. We get that, yes, 4,800. We go to D. What is our D line? It's another small triangle here, and therefore we talk of a half times our base. Our base is what? 400 minus 360, 40. 400 minus 360, 40. Then you multiply by our height. Our height is 80. So you work out this and you get what? 1,600 meters squared. Okay? So from there you go to E, this big figure here. This is a trapezium also. Two parallel lines are here. Two parallel lines are here, and you have the height. And therefore, the area of this trapezium will be a half. Some of the parallel lines are what? 280. 200, and the other one is 80. And then you multiply with the perpendicular from here to here. That is 360, Lana. 360 minus 80. 360 minus 80 will give you 280. You simplify this. This is a half multiplied by 280. Okay? Multiplied by 280. You work out this. You can divide like that. And then you multiply using a calculator. You should get something like 39,000 and what? 200 meters squared. 200 meters squared. Finally, Lana, we go to F. Maybe we can do it here. F. We go to F, Lana. What is our F? Our F is a triangle. And so we use a half times the base, Lana. What is the base? Our base is 80 minus 0, so 80. And our height is 200. So 80 times 200. You do the cancelling. This is 40. And therefore, the area for this triangle will be 8,000 meters squared, Lana. We are through with calculating the area of those regular shaped figures. So from there, Lana, to get the total area of the piece of land, Lana, you add all those areas. You add all those areas all the way up to F. And what should you get? You can use a calculator, and therefore you would get 79,200 meters squared. That is the total area. You need to show that working that you are adding. Remember that. And therefore from there, learn what is the area in hectares. What is the area in hectares? To get the area in hectares, learn. We know that 1 hectare is equals to 10,000 meters squared. 10,000 meters squared. And therefore, learn to convert these into meters squared, we do what? We divide by 10,000. We divide by 10,000. Therefore, you should end up with 7.92 hectares. 7.92 hectares. So learn, go and practice on how to handle survey questions. So you will always be given such kind of data. If you are given this kind of data, your baseline, for example, in this case, is from X to Y. And remember, our baseline was 400 meters long. So learn, these are offsets. These are offsets to the right and to the left. You come and draw these baselines horizontally, starting from X to Y, which is at 400, like we've done here. X all the way to 400. Remember, don't omit 400. So there we are. So then these two offsets go below. They go below the baseline, and these ones go above. So at 80, you come and fix your baseline. At 360, come and fix your baseline. And offsets. And those offsets are perpendicular to the baseline. Finally, you join all those points, you join the points, you come up with your area, the piece of land, the shape of your piece of land, then you calculate the areas of these plane figures. Finally, you add all of them to get the total area, and so you divide by 10,000 to convert into hectares. So all the best as you practice this Form 1s. Bye-bye.